Hello, and welcome back to the other part of 2-3. So here the book talks a little bit more about even and odd functions, which we did already talk about. So here's the definitions like written formally. So we want to think about looking at our picture here. There's t versus negative t. So if I take the sine of t, then that equals positive y. And we can kind of sketch in here. It's x over positive y up, negative y down. So sine of t is y. Sine of negative t is negative y. All right, so sine of t is not equal to sine of negative t. So we are not even. So since all the trig functions are even or odd, if it's not even, it's odd. I know, kind of a cop-out answer. Now this is just your basic trig functions with no other transformations. You put some transformations in there, you shift it around, that'll change things. But we'll see that more later chapters. So the sine of negative t is negative y. So if I up here multiplied by negative 1 on both sides, I have the negative sine of t equals negative y. And then down there, I know that negative y equals the sine of negative t. So the negative sine of t equals the sine of negative t. And again, if I just multiply both sides by that negative 1, then I get sine of t, my original function, is equal to the negative of sine of negative t, which is our definition for odd functions there. Now, I could follow all of that same logic with cosecant. It'd just be 1 over everywhere instead of just the y's, but same thing. So sine and cosecant are odd. All right, what about our cosine? So cosine of t is x, cosine of negative t is x. And that straight up matches our definition for even. So cosine and secant, its reciprocal, are even. Then the last one to consider is the tangent, which is sine over cosine. So the cosines are the same, but the signs change. So that forces tangent to also be odd. So sine and cosecant and tangent and cotangent. No, so I just wrote all of that up there instead of down here. That's all right. Now these functions are periodic. So the cosine is all the x values as we go around the unit circle. And then when we go around again, we're repeating the same exact x values. And then when we go around again, all the same x values. So sine and cosine are both periodic in 2 pi, a full rotation of the circle. Tangent and cotangent, it turns out, when you look at all the values for 2 pi, tangent goes through one set of values, and then it goes through the same set of values when it goes through the negative part of the circle. So just due to the way the sines and the cosines interact, and that the numbers repeat, when we look at the quotient, when we have those positive versus negative, which thing is negative is changing, but that doesn't change that the result for tangent would be negative. So that's why tangent and cotangent only have a period of pi. They repeat more frequently. So there's a lovely table with the list. Woohoo. If we start getting into more trig proofs, you really only want to go back and look for this if you see a negative sign in there. But our even ones, they can fold. Positive x's equal negative x's, or the y values associated with them are equal. So cosine and secant will like absorb that sign. Sine, tangent, cosecant, and cotangent, the sign comes out. Now here in our trigonometric expressions, there's no negatives here we have to worry about. So this one is just, we've got 2 trig functions or however much we'll have. And then it's asking us to simplify this. So there's a couple of ways to go about figuring things out for trig proofs, but like 9 times out of 10, best way to start is to write everything in terms of sine and cosine again. So for our first simplify here, secant of t over the tangent of t. Secant is 1 over cosine, and then tangent is sine over cosine with t's. Now, since we're dividing a fraction by a fraction, we can multiply by the reciprocal. I'm going to do something a little bit weirder though, but this can be really useful in trig identities. So I'm going to multiply by a weird form of 1. In this case, since I'm seeing cosine t on the bottom in both fractions, if I multiply by cosine t over cosine t, I'm multiplying by a weird form of 1. But then the cosine t's end up canceling everywhere. And we are left with 1 over sine t, which is cosecant t. Now, WebWork will not make you pick between those two answers. It'll tell you if it wants things only in terms of sine and cosine, or if not, then assume cosecant would be an okay answer. And the only reason we would call cosecant simpler is because we don't have extra math stuff going with it. Whereas 1 over sine has that 1 over. So it's like extra steps. Meh. All right, and then our other one, simplify tangent times cosine. All right, so remember tangent, sine over cosine. And now you're probably like, oh, I see what's about to happen. Yep, that's right. All that work to say that this is just sine of t. Done! With proofs. So write it all in terms of sine and cosine. Now, once we get more comfortable with these, we might have proofs that are a little more involved. So down here, we talked about the Pythagorean identity with trig functions. Since cosine is x and sine is y, and I can draw those in a right triangle, I can show that sine squared x plus cosine squared x is 1, as long as the x's match. Same thing here. And I'm getting those from being creative with the original. So I'm going to write the original here. So in your writing assignment, it asks you to take one of the alternate forms and show why it's equivalent to our sine squared plus cosine squared equals 1. So it's kind of like doing a trig proof. I'm going to let you guys think about it. All right, then we got 2 more. All right. So in this one, we're told the secant, and we're told that the angle is between 0 and pi. And we're asked to find the other 5 trig functions. So in order to be able to answer all the other 5 trig functions, we need typically at least 2 pieces of information. There's a couple of unique cases where if we only get one piece of information, we can answer the question. And that's like, where does sine equal 1? There's only one spot where the sine of x or sine of t equals 1. There's only one spot where the cosine of t equals 1. The same with negative 1. But any other value, there's more than 1. So we need some more information to narrow it down to one definitive answer. So this one here, we're told the secant is negative 17 over 8. So first things first, cosine is the reciprocal of secant. So the cosine is negative 8 over 17. And then the other thing we're told is that t is between 0 and pi. So now we're trying to figure out, well, where is it? Is it going to be the 0 to pi over 2? Or is it going to be pi over 2 to pi? Since our cosine is negative, our triangle is going to be over here in quadrant 2. Now, rather than say the cosine of our particular angle is negative 8 over 17, this is where I go back to my definitions of trig functions with their sides. So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is OA. Opposite over adjacent. So there's a couple mnemonic devices. One is SOHCAHTOA, like it's some weird bastardized Native American name or something. That still requires spelling and can trip you up if you're dyslexic, I think, a little. So with these, the one my dad told me when I was a kid was let me highlight them as I say it. Some old horse caught another horse taking oats away. So whenever I would do sine, cosine, or tangent, like that was what came in my head immediately. I was like, cosine, caught another horse, AH, adjacent hypotenuse. Another one that's a little funnier is some old hippie caught another hippie dripping on acid. So lots of ways to remember this. But hopefully this knowledge is like somewhere in the back of your brain. You should have seen it in geometry, even if it's been a while. So our cosine here, negative 8 over 17, that is the adjacent side over the hypotenuse. So the adjacent side goes to the left, because that's the one next to t, not opposite t. And that's where the negative is for our ordered pair. The x, the horizontal distance over, has to be negative. And then our hypotenuse here is 17. So in order to answer like what the sign is, we need to know the size of the opposite side. Well, I have two sides of a triangle, and I know it's a right triangle. So third side better be Pythagorean theorem. So we have -8 squared in parentheses plus, I guess I'll just call it y. Y squared equals 17 squared. All right, so -8 squared is 64 plus y squared, 17 is 289 minus the 64. Y squared is 225. We are choosing to apply the square root. So we introduce that possibility of plus or minus. 225 is actually 15 squared. So our y is positive or negative 15. Now we go back to the picture. Which direction is our y in? Is that going to be a positive y or a negative y? This one is a positive y, so we're going to fill it in as positive 15. Now we're just answering the other four trig. So the sign opposite the t is 15. Beneath, yeah, sure, the hypotenuse is 17. So the sine of t is 15 over 17. So the cosecant is the reciprocal, 17 over 15. And then we just have our tangents. So you can do the sine over the cosine, but you can also, looking at the angle, tripping on acid. So opposite over adjacent. So in this case, that's 15 over -8 without having to like write the full fraction and cancel anything. And then likewise, the cotangent is just the reciprocal, -8 over 15. All right, we don't have that much left here. We'll finish it out. Okay, so the sine of t is a negative square root of 3 over 2, and the cosine is positive 1/2. So that is actually enough to place our angle. The sine is negative, that's a negative y. Cosine is positive, so positive negative, way over here. Sorry, I realized I should use some color. All right, so our x distance is 1/2. Our y distance is a negative square root of 3 over 2. That does actually correspond to a point on the unit circle, because the 1/2 and square root of 3 over 2 tell us it's a 30, 60, 90. The side across is the negative square root of 3 over 2. So it'd actually be 60 degrees as the reference angle. All right, so we have sine, so we may as well fill out cosecant of t is -2 over the square root of 3. Because that's our reciprocal. And then we multiply by the square root of 3 over the square root of 3. We have -2 square roots of 3 over 3 squared is 9. Square root of 9 is back to 3. All right, now our secant is 1 over our cosine. So 1 over a half is 2. And now we just have tangent and cotangent. So our tangent, the negative square root of 3 over 2, divided by 1 over 2. The over 2's are going to cancel. We just end up with the square root, negative square root of 3. Oh. And then the cotangent of t is the reciprocal of that. And we rationalize. So we have the negative square root of 3 over 3. So that is just finding all our trig functions, given a couple pieces of information. All right. Now this one and all of our cardinal points, our multiples of pi over 2, have weird sines and cosines. So I would struggle with remembering which one was which. After a while, I'd have pictures in my head of cosine always started at 1, sine always started at 0. So I could use that to figure out where I wanted to go. Since the ordered pair for this point is 1, 0, and I know this is 0 degrees, that's how I would remember, oh, cosine goes to 1, sine goes to 0. But the one we're looking at is way down here, 0, comma, -1. So that means the cosine of t is 1 over our x value. And what do we do with 1 over 0? We can't divide that. So we call this undefined. All right, now our secant is going to be the reciprocal of 1 over 0, so 0 over 1. So the secant is 0 here. Wow, okay. Let's just like scratch that. My brain went la la la. You guys are probably like, whoa, she's tired. Whew, cosine is just the x. The x is 0, so the cosine is 0. It's secant that is undefined. All right, now our sine down there. The sine of t is -1. So the cosecant of t will be the same, -1. And then our last one's just tangent and cotangent. So tangent is sine over cosine. -1 over 0. Uh-oh. Undefined. Can't divide by 0. But our cotangent can. So when you have one of the four cardinal points, the pi over 2 or the multiples of pi over 2, you're going to get some weirder answers, including some undefined. So this tells us that the graphs of secant, and then if I flipped the order, eventually the graphs of cosecant, are going to have asymptotes because they divide by 0 potentially. We'll have to make use of that in a very weird way. All right, that is it for 2.3.